Yesterday we worked with exponential growth. Today we're going to work with exponential decay model. And as you can see over here, exponential growth model is y equals c parentheses 1 plus r close parentheses to the power of t. So our growth factor is 1 plus the rate. Over here on the exponential decay model, you have y equals c parentheses 1 minus r close parentheses to the power of t. 1 minus r is our decay factor. And as you notice with our graph on the growth model, our growth factor is going in a positive direction, whereas on our decay, we are going into negative. As I just said, our formula is y equals c parentheses 1 minus r to the power of t. As similar to our exponential growth model, y is our total, c is our initial amount that we're starting with, then 1 minus r is our decay factor, with r being our decay rate, and then t being our time. We're going to use this formula for these 4 problems. Y equals c parentheses 1 minus r close parentheses to the power of t. It says you buy a used car for $7,000. The car depreciates at the rate of 6% per year. Find the value of the car in given years. So let's start with C, our initial amount. The car was initially bought for $7,000. And it depreciates at a rate of 6%, and we need to convert that to a decimal. And our time for number 4 is 2 years. So we are going to find what the value of the car is after that 2 years. So we're going to have y equals 7,000. 1 minus 0.06 to the power of 2. We then combine what's in the parentheses. 1 minus 0.06 is 0.94. To the power of 2. Then next step is we take 0.94 to the power of 2, and we get 0.88. Next, we will multiply 7,000 times 0.88 and get $6,185.20. So the car's new value after 2 years is $6,185.20. We're going to use that same formula, but this time our years will be 5 years. So let's start with what our C is, 7,000. Our rate, 0.06. Our time is now 5 years. We're still finding the total value after 5 years. Make that correction up there. So we now have y equals 7,000 parentheses 1 minus 0.06 to the power of 5. We're going to combine what's in the parentheses. And we're going to get 0.94 to the power of 5. which then gives us 7,000 times 0.73. Then we're going to multiply 7,000 times 0.73, and we will get $5,110. That is our total amount value of the car after 5 years. Now we are going to work with a word problem. We're going to use our same formula, y equals c, parentheses, 1 minus r to the power of t. It says a business earned $85,000 in 1990. Then its earnings decreased by 2% each year for 10 years. Write an exponential decay model for the earnings E in the year t. Let t equals 0 represent 1990. So we're going to start by our variables. Our C is our initial amount earned, 85,000. Then our rate is 2%, which we convert to decimal, 0.02. Then our time is 10 years. We're going to find our y, the amount after 10 years that it decreased. So I'm going to have y equals 85,000, parentheses, 1 minus 0.02 to the power of 10. We're going to subtract what's in the parentheses and get 85,000 times 0.98 to the power of 10. Next, we will take 0.98 to the power of 10, which gives us 0.82 rounded. Our final step is to multiply 85,000 by 0.82, and the amount that the business decreased its earning by is $69,700.